Okay. So last week we've talked about one design pattern. At the bottom here, we've talked about the observer design pattern, and we've introduced the concept of what design patterns are and why they are important for software developers, for software engineers, and for computer architects, etc., for software architects in the future. Because I promoted design pattern as a way, if you study design pattern, it's a way to behave like expert software developers. And that is true, because you design, you learn simply there the way the experts are developing their softwares. And if some of you here worked at companies already, they might have already designed a few pieces, a few packages, and they are reusing these packages over and over again because they've realized that these are modular packages. I call them modular. They could be reused in one system or another. That observer design pattern we've talked about last week is from a category called behavioral design patterns, which to deal with making sure the behavior of that software is right at the expert level. Today we will look at another two categories of design patterns. I mean a group of design patterns like behavioral. We're going to look at the creational, and we're going to look at the structural. One way of looking and another way of looking how we could improve our software development. The creational design patterns are a group of design patterns, not just the factory and abstract factory here. There is more. I'll come to them in a minute. These group of design patterns, they deal with, let's say, the creations of things, the creations of classes, the creations of objects, the creations of a module, a framework, a subset of things, etc. The creations of images, of files, okay, in an expert way. At this moment, let's take it the most simple way is to deal with initializing, configuring, and creating, let's say, classes and objects. Okay, what does that mean? We'll talk about that in a minute. The other side is structural design pattern. Is how do we structure our project, maybe? How do we structure our class, etc. Or how do we integrate things together in our enterprise application development, okay? If we have a set of packages we've developed, these set of packages, we need to integrate them with other set of packages. What are the best ways to integrate them together? If we've just developed one class or a set of classes, and that set of class needs to interact with a legacy system, how do we manage that relationship, etc. We will talk about that, and we will give you an example or two of a design patterns. At this moment, the creational design patterns, they are there because they are encouraging us to design for change. Okay. What does that mean? For example, I'll give you an example that might bring something to your attention. If I'm playing a computer game, and that computer game is like walking through Oxford Road from here to the Heifer Road Junction, which is about half a mile from here. And you are designing that game, writing that code game, in which lots of objects will pop up in your face on the way. Does that make sense? And at the same time, you could take more than one path. You could walk on this side of the road, you could walk in the middle of the road, you can walk in this way of the road. So therefore, your decisions will affect what kind of objects are going to pop up in your face. Does that make sense? Okay. Therefore, all of these are going to pop up in your face on the way. These are objects. They could have images associated with them. They could have drawings, calculations, their movements. All of these are objects. I mean, obviously classes. Then you can instantiate them. Okay. If you design your system if you design your program so when you click start the game, all of these objects you're gonna see or not see are going to be instantiated. Okay? You're gonna say class X, which is the name of the class, X1 equaling new X. And therefore, if you're gonna do all of that at the start of the application, when you just say play, from the first second your program will stop, because all of these new instances, obviously, what's happened when we do create a new instance? We tell the computer system, hey, can you allocate some memory for this object? If this object has got 20 integers, 20 strings, 20, etc. Therefore, this is going to sit in your memory waiting to be used. Okay, if I say now, design for change, use the creational design patterns, I am deferring the creations of these instances until when I need them. Okay. So, therefore, there is something there solving that problem of the delaying the creation of these instances until a certain stage where I create these instances. Okay, how do we achieve that? And creational design patterns are meant to take care of that. There is a number of them for various usages. Okay. So therefore, one idea, can I have methods? At this moment, I'm talking in an abstract way, in a generic way. We might have methods which their responsibility is to create objects for you out of classes' names. Agree? You can design a class, and then within a method, you just give that method the privilege of creating instances. Okay. So, what are the list of creational design patterns? I'll move a bit fast on these because I'm going to be touching the first two, and next week is the last one. So, factory method is a method derived in a derived class, create associates, create objects, let's say for now. Abstract factory is a much more, it's building objects, a bigger list of factories. They allow us to build more instances for other objects. Builder, building complex objects incrementally in a more hierarchical structure. Prototype, cloning instances from a prototype, a larger systems, rather than just one single class instance. A singleton is a factory which is responsible on the creation and maintaining of a single instance only. We will talk about this next week, because that is useful. Sometimes you want, within an application, one single instance only of that class. And that single instance will be used by 500 classes. But all of them, they use that single instance. So there is a multi-threading issue, there is other issues inside. We'll talk about this next week. Maybe the best idea or the best example we could give now is talking about Java itself. And the uniqueness in Java is built based on the factory design pattern or based upon the creational design pattern. If you remember when you first joined this university and people started talking about Java, they told you Java is a multi-platform software development environment. Okay. And they told you then Java is, if you create your Java code.java, then you compile it using the JDK, you get a bytecode, these classes, you can take the bytecode of this software and run it in every operating system while that Java runtime environment is located within that environment. So they told you can run your code in Unix, Linux, Windows, and Mac. While other programming languages, for example, if you compile your code, your C++ code in this Windows machine, you can just take that code or that compiled code and move it to Linux, because it's not using something called the Java virtual machine. Therefore, the idea of a swing in Java is developed based on recreational design patterns. Therefore, it will adapt. If you take that application, which is a swing-based application with, you've got a J-frame or a window-based application. When you run it on the system here, you run it on Windows, it gives you the Windows application, window-based application. If you run it in Linux, it will give you a Linux-based architecture, a Linux-based window. The look and feel is different, but still you can run the code and it will give you the window you've designed. But the way the window look is different. The way the buttons look is different. But you didn't bother about that, did you? No. Because this is being done because the swing is already being designed to adapt to this change when they detect the underlying operating system. We'll go in further details in a minute so you can see the exact difference. Okay. So when do we use the factory design pattern? So usually, if I'm going to talk about the challenge before I say why do we need an interface, it's better. Here it's